Good morning, everyone. Can you hear me? Okay. Thank you for your responses. So, yeah, we are already 47. Let me just check your attendance. So, actually, we are 56, no? So, kulang pa tayo ng 9 person. So, sir, bagal lang net. Sorry po late. Okay. Sige, it's okay. It's early pa lang naman. It's only 10:34. So, wala namang kaso. Check lang po tayo ng attendance, no? Bago tayo magsimula sa discussion natin. Mr. John Mal Bangkil, Mr. Roger, Mr. Charles Patrick Bonifacio. Okay, present. Miss Christine Joy Nansilaw. Mr. Loyola, are you here? Siya. Mr. Maceda, Mr. Reynaldo Paligutan, Ay, present pala. How about Mr. John Patrick Santos? Are you here, sir? John Patrick, I think he's here. And John Matic. Mr. Patrick Viado. Okay. So majority are present. We can now proceed to the lecture. So today we're just gonna continue the discussion of fluid properties. I think we ended in this problem. So we'll continue with example 4. And then after this, we will discuss another fluid property, which is viscosity. Okay? If you are ready to learn and participate, please type ready in the chat box. Okay, I see a lot of you typed ready. So yeah, let's begin. So thank you for your responses. Let me share my other webcam. Okay. So we have example problem 4. To begin, let us first read the problem. The specific gravity of ethyl alcohol is 0.79. Calculate its specific weight in both pounds per cubic foot and kilonewtons per cubic meter, and mass density in both slugs per cubic foot and kilograms per cubic meter. Okay, so we have number 4. Let's write the given. So we have a fluid that is the ethyl alcohol, and we are given the specific gravity. And then the required are two fluid properties, which is specific weight and mass density. Now, for specific weight, we have to get the specific weight in both pounds per cubic foot and kilonewton per cubic meter. So both English and SI unit system. Okay? And then for mass density, we have to get it in slugs per cubic foot and kilogram per cubic meter. That is the required. Now let's go to the solution. What is the formula for specific gravity? Remember that it is the unit weight of the liquid divided by the unit weight of water. This is also equal to mass density of the liquid over the mass density of the water. So we want to compute the unit weight first, right? So we can cross multiply this unit weight of water to this side. It will become unit weight of the fluid and equal to specific gravity times the unit weight of water. Now, let us first get the unit weight of the ethyl alcohol in pounds per cubic foot. So, for the specific gravity, it's 0.79, the given. And then we multiply the unit weight of water in pounds per cubic foot. But what is that value? Can you give the unit weight of water in pounds per cubic foot? So yes, thank you, Francis. It's 62.4. Okay. Now, it's just like the unit weight of water in 9.81 kilonewton per meter cube. It's we have to remember these two. No? They are constants. Okay? So this is the unit weight of water in English, and this is the unit weight of water in SI. Okay? So very important in fluid mechanics that we know these constants. No? So 0.79 times 62.4. Can you help me solve this one? What's the answer po? Okay. 1.53. Thank you, Treb. This is pounds per feet cube. Tama ba? 0.79 times 62.4. Parang maliit. Okay. It's 49.30 pounds per cubic foot. Okay. So let's have the answer in 2 decimal places, no? Para dun sa final. So, thank you. No, thank you. What about the unit weight of ethyl alcohol in kilonewton per meter cube? So, again, we'll use this derived formula. No? So, we have 0.79 times the unit weight of water in SI. So, that is 9.81 kilonewton per meter cube. For the unit weight of water in Newton per meter cube, it's equal to what? 9,800 Newton per meter cube. Okay. Oh, yan. Now, what is the unit weight of ethyl alcohol? So we have 7.75 kilonewton per meter cube. Okay. So we have these two answers na, no? We also have to find the mass density. Okay, the mass density. So, to get the mass density of the ethyl alcohol, so again, we have to cross multiply this mass density of water to this side. So, this will become specific gravity times mass density of water. Okay, so we have 0.79. Now let us first get the mass density of ethyl alcohol in slugs per feet cube. But what is that value? What's the mass density of water in slugs per feet cube? Can you give that value? It's what? 1 point what? Okay, it's 1.94. Again, this is a constant. 1.94 slugs per feet cube. That's the mass density of water. Now, getting the mass density of ethyl alcohol, we have 0.79 times 1.94. Can you compute? So it's equal to what? 1.53. This is slugs per cubic foot. Okay. That's the mass density of ethyl alcohol in slugs per cubic foot. What about the mass density of ethyl alcohol in kilogram per cubic meter? Okay. The mass density of water is equal to 1,000. We have 1,000 times 0.79. So obviously, this is 790 kilogram per cubic meter. There you have it. That's our answers for example problem 4. Any questions po? Okay, wala naman. Sige. So, if wala, kindly answer this in a piece of paper. And after you're done answering, please take a photo and send your answer in our group chat. Okay? The first 3 that will get the correct answer will get GCash, no? Worth 50 pesos. Okay? So, yung pinaka mabilis na magsagot, nakatama, no? Yung unang 3. So, will get GCash worth 50 pesos. So, yan, no? Good luck. Kailangan tama, no? Ang hinahanap, mass density, specific volume, tsaka specific gravity. Okay? So, pasali daw po si Brian sa GC. Brian, can you send your FB link sa chat box natin? Okay, so John Clarence already has an answer. So tingnan natin, no? Sagutan din natin to after. Let's have a time limit para hindi naman masyadong matagal tayong maghintay. So, we'll answer this at exactly 11 a.m. Okay? So you still have 4 minutes to send your answers. Okay, it's already 11 o'clock. So let's answer this one. So there are a couple that sent their answers now. So let's see. Okay. So let us read first the problem. A certain gasoline weighs 46 pounds per cubic foot. What are its mass density, specific volume, and specific gravity? So we're only given what? What is this? Based from the unit, it's what? It is? Okay. It is the specific or unit weight. 46 pound per cubic foot. And then we are required to determine the mass density, specific volume, and specific gravity. Okay, so let's solve. Let's begin with the mass density. Okay, so remember that we derived the formula for unit weight in relation to the mass density, and that is unit weight equals mass density times the gravitational acceleration. So we just have to cross multiply this g dito. So this will become mass density equals unit weight over g. So this is 46.0 pound per cubic foot divided by what? What is the gravitational acceleration in English unit? It is 32.2. Okay, very good. It's 32.2 feet per second squared. So this will become what? 1.43. This feet per second squared will cancel the feet per second squared here in the pounds unit. No? So this will become slug per cubic foot. So that's the mass density of the gasoline. Okay. Now next, we are required to determine the specific volume. Now what is the formula for the specific volume? That's 1 over the mass density. So we have 1 over 1.43. This is equal to what? Approximately 0.7. This is feet cube over slug. Kasi ito is slug over feet cube. Okay? So aangat yung feet cube sa numerator. So that's the answer for specific volume. And then for the specific gravity, we can use either the unit weight or the mass density. So ang gamitin na lang natin is yung mass density. Okay? So 1.43 slug per cubic foot over the mass density of water, which is 1.94. Okay? Slug per cubic foot. So cancel yung unit. This will become what? 1.43 over 1.94. 0.74. Okay? We have no unit. Ito po yung answers natin. And kailangan complete yung solution tsaka tama yung units. Let me check kung sino yung pinakaunang nag-send. So si Mr. John Clarence. Okay, he is correct. So congrats. Please send me a private message. No. Please send your GCash number. And I will give it to you after our conference. Okay? So, PM mo lang ako mamaya, John Clarence. Tapos yung sunod is si Mr. Lawrence. Okay, medyo Nalilito ako kasi walang ano eh, box eh. Class, if you will solve problems, no, for the final answers, please box them o kaya i-underline nyo, no? So para hindi tayo mahirap pag-check. I think mali siya sa mass density. Okay. So better luck next time, no, Mr. Lawrence. So let's go to the next, si Mr. Jorens. Okay. So he's correct. Mr. Jorens, please also send your GCash account. And then we have Mr. MJ. Mali siya, no? Kasi I see naka-SI. So si Mr. Kurt. Okay, so tama siya. So Mr. Kurt, please message me then privately. And I will send you the 50 pesos later, no? After our conference. Okay? So, yeah, congrats. And thank you for answering. Do you have any question with that problem? Okay, wala. Sige. So, if none, we'll continue to the other fluid property. Sir, saan po makikita yung notes? I will post this PowerPoint in your Canvas after this conference, Jerby. Naka-upload na yung PDF na to hanggang dito lang. Okay? So mamaya I will delete that PowerPoint and then I will upload this instead. Okay? Para kompleto. Sige. So, yeah, let's proceed to this fluid property, no? Another fluid property. So we have viscosity. So what is viscosity? So when we say viscosity, it is the property of a fluid which determines the amount of its resistance to shearing stress. And this viscosity is often represented by the symbol mu. Okay? It's represented by the symbol mu. Now imagine we have different fluids. We have water, oil, and gasoline. So when we pour these fluids into containers, we can notice na yung iba sa kanila malapot. Okay? Malapot. So we can see, no, that the oil is looks more thicker than water. Okay? Now, the viscosity, okay, viscosity has something to do with that flow. Okay? So, it says here that a perfect fluid would have no viscosity, and the viscosity of liquids decreases with increasing temperature. whereas the viscosity of gases increases with it. Ayan. So, para mas maintindihan natin, no, yung topic, no, yung viscosity, let us look at this figure. Okay? Let's focus on this figure. So, at different layers of fluid, they have different velocities. Okay? They have different velocities. So, the velocity here at this layer, so imagine we have 1, 2, 3, 4 layers. Okay? We have 4 layers in this fluid. So, again, the velocity on this layer is different from this layer. It's different from this layer. And it's different from this layer. Okay? By the way, this is called velocity gradient. No? This is called velocity gradient, in which we can see the different velocities of each of the layers. Okay? And these layers, they have friction with one another. They experience friction. Okay? So, this layer experiences friction with this layer, also with this layer, also with this layer. Okay? Now, bakit naging ganito yung velocity gradient ng fluids? Well, at the bottom of this container, meron tayong solid bottom, right? So, yung tubig dito will experience friction. Okay? It will experience friction. So basically, the velocity of this layer of fluid is will be smaller than this fluid because of the friction between the solid bottom, the container, and the liquid at this portion. And as we go up, the velocity increases because at this point, wala nang masyadong friction eh. Okay, at the top. That's why the velocity gradient of fluid looks like this. Okay, it looks like this. Now, we have what we call shearing stress. So, when we say shearing stress, it's the stress caused by forces in parallel. So, kung meron tayong ditong dalawang layer and then they are sliding past each other, basically at the layer between them, it experiences shear stress. Okay, it experiences shear stress. So that shear stress can be represented as this symbol. Okay, can be represented as this symbol. Now, we can look again at this velocity gradient, no? And we can notice the slope at different sections. Okay, so we have a slope. Okay, we have a slope. So this side can be represented as dV, and then this one can be represented as dy. Okay? So, now, looking at this um, figure, no, the shearing stress can be related to the slope dv over dy. Okay? dv over dy. And as we increase the amount of shearing stress, the dB over dy also increases. So basically, they are um, linearly related. So they are um, directly proportional. Okay, and the constant of proportionality is the viscosity. Okay, so it's the constant for constant of the proportionality. Now, given that this is the constant of proportionality, this will be equal to what? We have rise over run. Okay, rise over run. So viscosity will be equal to the shear stress over dV over dy. Okay, in which dV over dy is the change in uh, velocity with respect to the depth. Okay? Kasi as we change the depth in the fluid, okay, as we change depths, the velocity also changes. Right? So we have this dB over dy. So again, rise over run, no? Shear stress over dB over dy. No? Now, in computing the shear stress, we can cross multiply this dB over dy, and we will come up with this equation. Okay, we will come up with this equation. And that class is the Newton's law of viscosity. Okay, it's the Newton's law of viscosity. And this law states that the shear stress is directly proportional to the shear strain rate or velocity gradient. Okay, so remember, no, shear strain rate or velocity gradient. Now this is the velocity gradient. It can also be shear stress equals viscosity times the shear strain rate. So that's the um, what do you call this? Delta. Yeah, thank you. D delta over dt. Okay. So the rate of change of uh, the strain with respect to time. Okay. So these are the equations to familiarize. Okay. So with that, let us answer a sample problem. So we have example problem 5. No? So let's read the problem first and then let's solve. When the force P is applied to the plate, the velocity profile for a Newtonian fluid that is confined under the plate is approximately, okay, so hindi dyan kita, pero it's equal to, or the velocity is equal to, wait, okay, 12y raised to 1/4 millimeter per second, where y is in millimeter. Determine the shear stress within the fluid at y equals 8 millimeters, and then take the viscosity, I take the viscosity to be 0.5 times 10 raised to negative p, raised to negative p Newton second per mm squared. So let us solve this one. No? Let me share my other camera. Okay. So we have problem 5. We are given the velocity equation. 12y raised to 1/4 mm per second, where y is in millimeters. And then we have y, okay? We have y equal to 8 millimeters. And then we are given the viscosity. 0.5 times 10 raised to negative 3 Newton second per meter squared. Now, what's the required? The required is the shear stress. Okay. So let's solve. What's the formula for the shear stress? This viscosity times the derivative of the velocity with respect to y. Okay. So we are given the viscosity. We just have to determine the derivative of this velocity equation. Okay. So let's have dv over dy. This is equal to derivative of 12y raised to 1/4 respect to dy. Now let's differentiate. So this will become 1/4 times 12. What is that? We have v. And then we'll have y raised to 1/4 minus 1. So this will become negative 3/4. And then our y is equal to, okay, so we now have the equation, no, for dB over dy. So So we can solve the shear stress. Okay. So shear stress is equal to 0.5 times 10 raised to negative P Newton times second over meter squared times. We have P times. So y is equal to 8. So we will substitute this. This will become 3 times 8 raised to negative P4. What is the shear stress? Okay. It's 3.15 times 10 raised to negative 4. This is in pascals. Okay? So when we say pascals, this is equal to Newton per meter squared. Ah, raised to negative 3. Ayan. There you have it. That's the answer. Okay. So this is our last problem for the day. Sample problem 6. Let us read. SAE10 oil at 20 degrees Celsius is sheared between two parallel plates 0.01 inches apart, with the lower plate fixed and the upper plate moving at 15 feet per second. Compute the shear stress in the oil. We are also given the viscosity of the SAE10 oil. Okay, so slightly given. We have the viscosity 1.7 times 10 raised to negative P pound second over feet squared. Now maganda in this kind of questions, no, na walang figure, i-drawing muna natin yung figure. Okay, para mas ma-imagine natin, no. Mas madali nating malaman yung sagot. So, sabi, the oil is sheared between two parallel plates. You have plate at the top, and then you have plate at the bottom. Then you have the SAE, then oil between them. So, it says that the two parallel plates are 0.01 inch apart. and the upper plate is moving at 15 feet per second. So basically, it has a velocity of 15 feet per second. Now, we just have to compute the shear stress. Okay. Now, again, what's the formula for the shear stress? It's equal to the viscosity times dV over dy. Okay. Now, we are given the viscosity. So, let us write that down. 1.7 times 10 raised to negative 3 pound second per feet squared. You can see that we need the velocity, but we have a numerical value, no? That's 15 feet per second. So, yan yung i-consider natin, no? So, 15 feet per second, and then we have the y. Okay, also given 0.01 inch. So, that will be our dy. Okay? 0.01, we just have to convert this to feet. Okay? So 0.01 inch, divide this by 12 inch per foot. Cancel yung inch, magiging foot yung denominator mo. So, this will cancel out, and then this will cancel. Ang matitira is pound per squared foot. Okay? Now, can you give the value of shear stress? Okay, it's equal to 30.6 pound per squared foot. Okay, so any questions? That ends our discussion for today. Okay, so let me just check again your attendance. Mr. Bangkil, Janmar, Mr. Roger, Paok, are you here? Hindi dito siya. Okay. Miss Christine Cancilaw, Mr. Loyola Terence, Mr. Maceda,
Present po, sir.
Mr. Patrick Viado, dito na. Okay. Okay. Miss Andrea has a question. Sir, sa volume po, pag integer lang, walang equation, di na po need ng derivation. Yes, kapag velocity, no, yung given, there is no need for derivation. Okay? So, ang kailangan natin doon is value ng velocity tsaka yung y. Okay, di ba? dv over dy. Okay. So, kailangan natin yung numerical value ni velocity tsaka numerical value ni height. Okay? Numerical value ni height. Now, if given tayo ng equation ni velocity, like for example, 6y squared. Yan. We have to differentiate this equation. Saka natin siya pwedeng magamit to solve for the shear stress. Okay? So, again, we differentiate because the velocity has something to do with the height of the fluid. As velocity changes or as the height changes, the velocity also changes. Okay? At the bottom of the container, we experience the lowest velocity because yun yung fluid na direct in contact with the solid container, no? The solid bottom. So, mabagal lang yung flow ni fluid doon. And as we increase the height, the velocity also increases because mas lumiliit yung friction. So, kaya we have this velocity gradient dito. And getting to the core of differential calculus. No? Bakit ba tayo nag-differentiate? We differentiate to get the rate of change. So, yan, no? We have this dv over dy. So, multiply it with the viscosity, we get the shear stress. Na itong equation na to, galing siya dun sa relationship ng dalawa. Okay? Kasi as we increase the dv over dy, we also increase the shear resistance. So, they are directly proportional. And the constant of proportionality is the viscosity. Now, if we will put it in an equation, rise over run, so shear stress over dv over dy, cross multiply this to this side, so you have this equation. Yeah, just a review lang. No? Okay. Upload nyo po mamaya, sir, yung notes. Yes po, after this conference. Any questions? Any question pa? Okay po. So, yes, pati solutions sa GC natin. Paul, send ko yung solutions. Okay. So, yan, no? It's already 11:40. So, if wala na pong tanong, wala nang concern, you may leave the conference. I will see you all on Thursday. Let's continue our discussion, no? By Thursday, 10:30 a.m. Okay? So, thank you for your attention. Thank you for coming to the class today. I hope you learned something and take care. No? Have a great day, everyone.